Hello everyone, today in this video we are going to study the medium access layer of the wireless LANs. In the last video we have seen the physical layer. Now in this video we will see first part of the MAC layer of the wireless LAN. So medium access control layer in any kind of network, whether it is a wired network or wireless network or mobile network, its primary job is to control the medium access. That means how users are going to access the available medium, whether it is based on sharing, whether it is based on competitiveness or anything else. So that is the primary job of the medium access layer. Now apart from that, it also supports or it also provides support for roaming, authentication and power conservation in wireless LAN. Now in wireless LAN, roaming means changing a foreign agent. When a user moves from one foreign agent to another foreign agent, it will be called as roaming. Okay, this is different from roaming in the GSM. Okay, so authentication means whenever you move into or get in the range of the particular foreign agent or access point, then you have to authenticate yourself in order to communicate. And finally is power conservation. When you don't have a data to transmit, your power should be saved because you are idle. So that is the power conservation. Most of these tasks are done by the access point. That means medium access layer is primarily controlled by the access point. So this MAC layer offers two types of services. First one is a mandatory one that should be implemented by every particular entity inside a wireless LAN, that is called as asynchronous data service. Okay, so as the name suggests, what's the meaning of asynchronous? It does not have any time binding or time restrictions on it. That means exchange of data packets are based on best effort. Okay, so first property of asynchronous data transfer is exchange of data packets based on best effort. Best effort means a sender sends the packet, then packet delivery is not guaranteed. That means the layers involved in the packet delivery will try to deliver a packet as high as possible, but they cannot guarantee the delivery of the packet. So in wired networks, transport layer protocol called as a UDP provides this best effort kind of service. Okay, so there is no acknowledgement in UDP. So similar to that, in the MAC layer, asynchronous data services are based on best effort. Then second property of asynchronous data services is they support both types of packet, that is broadcast, multicast. Obviously it also supports unicast packets. So broadcast and multicast packets are also supported by asynchronous data services. And third property, one of the important, as this is a mandatory one, both types of network, that is ad hoc and infrastructure, both types of network offer this type of traffic services. Okay, traffic services means how traffic, that is user data, will be serviced by a access point or by a medium. Okay, these are the first services or properties of a first service. Then time bounded services, this is optional one, it's not a mandatory one. Time bounded services means services or communication that is restricted to time, like video streaming, audio streaming, where time is important parameter of a communication. Okay, so these are time bounded services. These are supported only by the infrastructure networks. Okay, that is important to note. In this case, as it is supported only by infrastructure network, access point coordinates the medium access. Users do not have a chance to decide how they are going to access the medium. Access point will decide how each user will access the medium. Okay, so that is the type of services these are followed by or offered by MAC layer of a WLAN. Okay, so let's go into detail of each service. So similar to physical layer, MAC layer of the IEEE 802.11 provides three basic mechanisms for medium access layer. In physical layer also we had three basic mechanisms for physical layer. Now here we have three mechanisms for medium access layer. So IEEE has standardized these mechanisms. So the first one is a mandatory one. That means each node should implement this particular mechanism in its node itself. That is called as, it is based on version of a CSMA CA. Okay, it is not CSMA CA. It is based on version of CSMA CA. Okay, CSMA CA, carrier sense multiple access with collision avoidance. So based on CSMA CA, there is one version that is called as the first method of the IEEE 802.11 medium access layer. Okay, then second method is a optional one which is used for avoiding hidden terminal problems. Hidden terminal problem we have studied during previous chapters. That can be also observed in case of wireless LAN also. So those problems can be solved by the second method. Then third one is completely different method. In this method, polling is used for time bounded services. So this method is specifically designed for time bounded services. So we will see each of these methods one by one. Today in this video we will see only first one. Okay. So before studying these three mechanisms, let's look at some of the important parameters that we should understand while understanding the working of medium access layer. Okay, so moving towards that thing, the first two methods that these are called as DCF, that is distributed coordination function. That means these medium access are not controlled by a single entity, but it can be distributed amongst the different nodes. Nodes will mutually decide how to access a medium and how to communicate or send a packets within the medium. So that's why they are called as distributed coordination function, DCF. Okay, whereas third one is known as PCF because it is controlled by access point, so it is known as point coordination function. Okay, so these are the names DCF and PCF which are given to medium access mechanisms in the wireless LAN. DCF offers only asynchronous service. Okay, both are these only for asynchronous, whereas this is for time bounded service. PCF offers both asynchronous and time bounded services, but needs an access point to control a medium access to avoid contention. Okay, so DCF, this is DCF, offers only asynchronous, whereas PCF offers both asynchronous plus time bounded. But in case of PCS, even for asynchronous services, you will require an access point to avoid a contention period. Contention period means period in which users will compete with each other for accessing a medium. This is important. Contention period is a period in which users will compete with each other for accessing a medium. Okay, so these are the functions in the wireless LAN MAC layer, and these are the services which are provided by these functions. Okay, so the MAC mechanisms, these are called as technically DFWMAC, that is distributed foundation wireless medium access. That is the full form of the DFWMAC. So from now onwards we will use this terminology for mentioning each and every mechanism. Okay, so let's look at those parameters which we should learn before understanding all these mechanisms. So the three mechanisms, they are technically now renamed to these three parts or these three names. First one, first access method is DFWMAC-DCF, CSMA CA. This is mandatory as we have seen already. Second one, DFWMAC-DCF with RTS CTS. This is optional. Now see, both are DCF based. First one is CSMA based, second one is hidden terminal problem solving based. So it is using RTS and CTS packets for solving the hidden terminal problem. And third one is based on time bounded services or providing time bounded services based on the PCF. This is also optional one. So as we can recall about CSMA-CA uses a back-off mechanism. We will see how that back-off mechanism works in the CSMA-CA in terms of wireless LAN. So that is taken from the CSMA-CA, that collision avoidance technique. Then it provides a minimum distance between consecutive packets. This backoff ensures that two packets are not consecutively sent. There is some gap between two packets, and that gap avoids the collision. Okay, that is how we are going to work, that we will see in detail afterwards. So it for multicast or unicast packets, acknowledgement is demanded in this particular scheme. So ACK packet for acknowledgements is used by this particular method, but it is not used for broadcast packets. Okay, then second method, as I said, it is for solving the hidden terminal problem, and it is based on the MACA method that we have studied in the first chapter. Okay, so it is using RTS and CTS packets. We will see that later on. And third one is based on polling. Polling means asking each user one by one about whether they want to access a medium or not. Okay, again we will see that in detail afterwards. For all access method, several parameters are important. So what kind of parameters? I said that packets are not consecutively sent. There is a certain waiting period in between. So how much waiting period it should be? For that, there are several parameters defined by IEEE for controlling waiting time before medium access as well as packet transmission. Okay, usually in a wired services, whenever a packet arrives at a MAC layer, that is for transmission, if the medium is free, immediately it may be transmitted. So that does not happen in case of CSMA-CA. So how it happens, we will see that during the detailed explanation of this technique. But certain waiting period is always there before transmission, and for that we will study these different parameters. Okay, so these are called as DFWMAC priorities. That is, who will get a first priority for transmission of a packet. That is based on the waiting period it has to follow by defined by the IEEE. So the figure which will be shown on the next slide, three different parameters that are defined by IEEE, which defines the priorities of the medium access. Okay, which one will get a first access to the medium, which one will get the second access, and which one will be getting the last access to the medium. The values of these parameters are dependent on several different things, like physical layer implemented, whether it is based on infrared, FHSS, DSSS, based on that, plus the slot time that is employed by that physical layer. What is slot time? Slot time is derived from the medium propagation delay. That means how much time it takes to deliver a packet from sender to a receiver. That is propagation delay. Okay, how much time it spends in the air, that is propagation delay. Then transmitter delay, how much time it takes to transmit a packet from a node towards the medium. Okay, if a packet size is 1 GB, that will never be the case, but just for example, if packet size is 1 GB, the transmitter delay will be much larger compared to if a packet size is 1 byte. 1 byte data can easily be transmitted, but 1 GB data takes a lot of time for transmission. There are several other physical dependent parameters or physical layer dependent parameters which decide the slot time. So for slot time for FHSS is 50 microsecond and slot time for DSSS is 20 microsecond. Okay, because FHSS is slightly complex than the DSSS in terms of a transmission technique. Okay, So these are the slot times, and based on this slot time our three parameters will be defined. Okay, so the medium can be busy or it can be idle also. So based on that you have to wait. How much wait? Based on these three parameters. Okay, if the medium is busy, this can be due to ongoing data transmission or ongoing control packet transmission. Okay, during the contention phase several nodes try to access the medium, so at that time also a backup timer will be activated at each node, and that is based on also again a slot time. Maybe the contention period will be of 10 slot times or 20 slot times depending on number of users available in the medium. So let's look at these slot times. So three waiting periods that are defined by IEEE are known as SIFS, PIFS and DIFS. SIFS stands for short interframe spacing, PIFS stands for PCF interframe spacing, and DIFS stands for DCF interframe spacing. So the waiting period for DCF is DIFS, waiting period for PCF is PIFS, and waiting period for control packets is SIFS. Okay, that is the summary of it. So let's see the SIFS. SIFS is of a highest priority. That means this is a shortest waiting time. Remember, highest priority means shortest waiting time. If a node has to wait for shortest waiting time, that means that particular node has a highest priority. Okay, so this type of waiting time is preferred for sending control packets, that is acknowledgements, CTS packet or polling response, okay, or polling request. That type of packets are sent after waiting for SIFS amount of time. How this diagram works we will see later on at the end of this particular DIFS. Okay, for DSSS this SIFS is 10 microsecond, for FHSS it is 28 microsecond. Okay, so that is predefined by the IEEE 802.11. So SIFS has a priority 1. Then PIFS, it has a second priority, that is medium priority. That means it is neither slowest or longest waiting time nor it is a shortest waiting time. It is in between longest and shortest. So it has a medium priority. It is used for time bounded services using PCF. So how much is a PIFS? PIFS is equal to SIFS plus 1 slot time. Okay, so that is PIFS. So whenever a node is using a time bounded service of PCF, it has to wait PIFS amount of time before it can send a packet. Okay, then third one is a DIFS, that is a least priority, that means lowest priority. So it is used by asynchronous data services offered by DCF and PCF. Okay, so DIFS is used for asynchronous data services. How much it is? SIFS plus 2 slot times. Okay, so that means if a node wants to transmit a data packet in a asynchronous data service mode, then it has to wait DIFS amount of time before transmission. Okay, so I hope all the three parameters are clear now: SIFS, PIFS and DIFS. We will see one example how that works, but let's now get to the diagram. So let's say node 1 wants to transmit a packet and packet has just arrived at the MAC layer. Then let's say this is using asynchronous data service. So if it is using asynchronous data service, how much time it should wait before accessing the medium? That is DIFS amount of time. So that's, you will see it is waiting for DIFS amount of time and then checks whether medium is busy or free using a CCA, that is clear channel assessment. Of if the medium is busy, it will further wait. If medium is free, direct access to the medium if it is free, and that is after DIFS amount of time. Okay, so after waiting for DIFS amount of time, if medium is free, you can directly access the medium. Okay, so that is the meaning. Now once it starts accessing the medium, it can send a data packet. So medium becomes busy now because node is now transmitting packets. Now let's see what are SIFS, PIFS and DIFS. These are waiting times. So you see, if there was only a single packet that was sent, then it will be expecting a acknowledgement. Now acknowledgement may be given or it may not be given also, as this is a asynchronous data transfer, there will be no acknowledgement. So let's assume that packet transmission is complete, there is no more data to be transmitted by node 1 or this particular node. Then other terminals or other nodes within this wireless LAN or other users within this wireless LAN will try to access a medium. Okay, so there will be a competition between these users to access the medium, but it does not start immediately. Okay, depending on type of service they are getting, that is, if whether it is time bounded or asynchronous or any other, they have to wait this much amount of time for beginning the contention period. Okay, so this amount of time is a waiting period before contention period starts. Contention period, again as I said, is a period during which users will compete with each other for accessing the medium. If a user has a time bounded service offered by PCF, it will wait for only SIFS time. Okay, if a user, sorry, PIFS amount of time, not SIFS, PIFS amount of time. SIFS, if a user wants to send a acknowledgement, it will wait for SIFS amount of time. And if another user who is getting asynchronous data service, then it has to wait for DIFS amount of time. After all these times, contention period will begin. They will compete within that contention period with each other, and after that they can transmit if the medium is free. Okay, so how this contention happens, that we are going to see now with one example. How does a contention period works? So first method we are going to study to understand the contention period. First method offered by IEEE 802.11 MAC layer is called as DFWMAC-DCF using CSMA CA. Okay, so a station ready to send starts sensing the medium via CCA. Okay, let's say a packet arrives at a MAC layer. So a station knows that it has a packet to send, so it starts sensing the medium with the CCA. Now first condition, medium is free. If the medium is free, so what it can do, it will wait for DIFS amount of time. As we have assumed, this is a asynchronous data service. Okay, so if the medium is free for duration of a interframe spacing, station can start sending. So after waiting, if medium is free, here medium is supposed to be free, so it has started the transmission process. Okay, if medium is busy, the station has to wait for a free IFS. Okay, if medium is still busy during this, then it has to further wait until medium becomes free. So that is again dependent based on your interframe spacing time. Okay, then third situation, if another station is occupying the medium during back off time of the station, the back off timer stops. That is called as a fairness. Now this is important. Now after waiting for DIFS amount of time, our contention period will start for sending the next packet. Now during this period, it observes that another station is occupying the medium. So how much time it should wait before start sensing again? Now that is based on the back off timer, how much time it will wait, and that is stopped if medium is busy to avoid unfair advantage to other users. Now how this is done, let's take an example. There are 5 stations in this particular medium. We are implementing DFWMAC-DCF with CSMA CA. Now station 3, this arrow indicates packet arrival at a MAC layer. Okay, that means station 3 has a first priority because it gets a packet first at a MAC layer. After that, station 1 will take a packet second, because packet arrives at station 1 immediately after that. Station 5 will have a third chance because packet arrives earlier than station 2, so that is the fourth chance. And finally packet arrives at station 4, that's why it will be the fifth priority. Now this is packet arriving at each station. These packets are different packets. Each one wants to transmit a data. 5 stations wanting to transmit a data, but a packet available for transmission is at a different time. Station 3 is first ready for transmission of a packet. So what happens now? Let's see. Now station 3 packet arrives very early at station 3. So you can see here. So it waits for a DIFS amount of time. After waiting for that, it start transmitting. So medium becomes busy. There are 5 stations. For other 4 stations, medium is now busy. Okay. Now while it is waiting for DIFS amount of time, station 1, at station 1 also packet is ready for transmission, so it will start waiting for DIFS amount of time. Okay, but that we will see, or that we will discuss later on. Okay, now medium is busy. After completion of packet transmission, again DIFS amount of time will be used for waiting period for all the stations. Okay, once this DIFS ends, contention period begins. So this is contention period. Now during this contention period, what happens? You will see different terminologies like BOE, BOR. Okay, what is BOE? Elapsed back of time. BOR is a residual back of time. So what's the meaning of this? When station 3 started sending, all these stations 1, 2, 4, 5 paused their back of timer. Why? Because once they were waiting, during that time medium become busy. So when they are waiting period is started by a back of timer. It may be of several slot times. Let's say 5 slot time, out of which after elapsing 2 slot times medium become busy. So as soon as medium becomes busy, it is stopped. So remaining is 3 slot times. So elapsed back of time is 2 slot times and residual back of time is 3 slot times. Okay, so once elapsed back of time is over, medium becomes busy, and that's why timer is stopped. Okay, how that works, let's see now. The last statement that we have seen, fairness, back of timer stops, fairness, we are seeing that thing now over here. Okay, now station 3 has completed data transmission. After waiting for DIFS amount of time, contention period begins. Let's say station 2, 1, 4, 5 all are in contention. 4 is not yet in contention because packet has not yet arrived at the, this is where we are at, and packet is yet to arrive at a station 4. So this is not in question. So who are competing now? Station 1, station 2 and station 5 are competing for the medium access. Okay, so what will happen now? Contention period starts. Now all these 3 stations will start with a random back of time. Let's say station 2 chooses 2 slot times as a random back of time. Station 5 chooses 4 slot times as a random back of time, and station 1 chooses 7 slot times as a random back of time. So who is getting a first access to the medium? Of course station 2. Why? It was setting, or it had already set back of time equal to only 2 slot times. Okay, so all stations starts their back of timer. 2 slot times are over. Station 2 starts sensing the medium, finds the medium free, start transmission. So medium becomes busy because station 2 has started the transmission. So after completion of two slot times, station 5 and station 1 stops their timer. So elapsed back of time for station 1 is 2. Elapsed back of time for station 5 is 2. What is the residual back of time for station 1? 7 minus 2, that is 5. Okay, let's draw it again. Elapsed back of time for station 1 is 2. Residual back of time is 5 because it was using a back of timer of 7. Sorry. So it is 5. Elapsed back of time for station 5 is 2. Residual back of time for station 5 is 4. Okay. So remember this 5 and 4. After station 2 completes the transmission, again DIFS amount of time is waited. Now how many stations are there? 1, 5, and now packet has arrived at station 4 also. So 4 will be also in contention for the next contention period. Now in this period again back of timer starts. Now station 4 starts with the back of timer of 5. Okay, now forget about elapsed back of time. Okay, now station 4 is started back of timer of 5. Now what is the residual back of timer of 4 and 5, or let's say this is 6 for simpler calculation. Let's say this is 6. So station 4's remaining back of time is station 1's remaining back of time is 5 and station 5's remaining back of time is 4. So 4 will complete first. It will sense that medium is free. It will start transmission. So medium becomes busy. Okay. Now just a slight modification. We will take station 4 back of time equal to 4. Okay. This is remaining is 4. This is remaining is 5. Okay. So station 4 elapsed back of time is 4. Station 5's elapsed back of time is 2 and remaining back of time is 4. Station 1's is remaining back of time is 5. So 4 will complete first. This 4 will also complete. But since this is the residual back of time, it will access the medium first. And since station 4 has a entire back of time elapsed, but it has entered the frame or entered the contention period later on. These two stations were already in contention. This is the new entry. That's why there may be a collision in that case. So that to avoid this back of time should be larger than other two. So that for that reason it should be taken as 6. Okay. So once 4 are complete, one back of residual back of time is still remaining, which will be implemented here, and station 1 can transmit in this particular time period. Okay. So once this collision occurs, it will increase the back of time to 6. So out of which 4 are already complete, or a new timer is already assigned. So again one period is elapsed. This is what one period is, and remaining are 5 residual back of time. So this is how fairness is achieved. Otherwise what would have happened if there is no fairness? What would have happened? Since station 5 had a residual back of time of 4, station 4 back of timer 4, station 4 could have got access to the medium, but because of fairness offered, residual back of time gets the first priority and station 5 gets a chance to transmit the packet first. Residual back of time of 1, that will be carried forward to the next transmission phase. Now station 4 and 1 will be in contention. Now back of timer remaining for station 1 is only 1, so it will get a first chance for transmission of packet. So station 4 will always get a last chance to transmit a packet because packet arrived at station 4 last among all the 5 stations. Okay, so that is the fairness achieved via this particular method. Okay, so let's see simple communication between uh, two nodes using this particular technique, sending the unicast packets. Now this we have already discussed. This is a sender, this is a receiver, and these are the other stations. So as we are using asynchronous data service, sender has to wait for DIFS before sending a data. Once it sends, the medium is free, it starts sending a data. Okay, receiver provides the acknowledgement after waiting for SIFS amount of time. Why SIFS? Because we have to, or receiver has to send acknowledgement. Acknowledgement is a control packet, and for control packets waiting period is only SIFS amount of time. Okay, acknowledgement is said, communication between sender and receiver is over, so medium becomes free again. Other stations will again wait for DIFS amount of time, contention period will begin, and procedure will follow. Okay, so that is how packets are sent using the first scheme. The next two methods, that is based on RTS CTS and polling, that we will see in the next video. That's all for today. Thank you.